Hello everyone, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. So in previous classes, we discussed the introduction of machine tools and metrology. So in this class, I would like to explain about the nomenclature of the single point cutting tool. In previous class, we already discussed the types of cutting tools, single point cutting tool and multi-point cutting tools also. Okay. So these are the multi-point cutting tools and single point we use in lathe machine. We'll see the nomenclature of the single point cutting tool. Okay, this one is the course outcome which is related to this topic. Recall the importance of geometry of cutting tools, coolants, tool materials for the analysis of material behavior during manufacturing processes. So we'll see nomenclature of the cutting tool. What are the different parts and the different angles are included, uh, incorporated in the cutting tool, single point cutting tool. Okay. Now let's see first of all what are the different parts of the cutting tool. So this is the just like a block diagram of single point cutting tool. So this one is nothing but a shank. You can see the name of this portion. Okay, the main purpose of this shank to hold the workpiece in a cutting tool, okay, in a tool post. Okay, so this portion will be used to cut the material from the workpiece. This portion will be hold the cutting tool in the tool post. You'll see here. So this one is the shank is nothing but the body of the tool. This is the body of the tool, which goes into the tool holder or holding device, tool holder. Okay. So, or in simple language, shank is used to hold the tool. So, out of this portion, we go to the tool post. Okay. So, by fixing this tool, we can perform the different operations. Okay. This is the main purpose of the shank. Now, we'll see the first two. This is the face. What type of face? Rake face. So this is very important. On this face, the chips will move, or chips moves continuously, or chips will be removed and machining. So by the support of this rake face, okay. We'll see what is the importance of this one. Face, rake face. It is the top portion of the tool. So along which chips slides. So it is designed in a such a way that movement of this slip or sliding of the chips on it in upward direction. So that is the main importance of the sloping of this face. So this is nothing but a rack face. So next one we'll see the plank. So plank, we'll see this is the major plank. This one is the minor plank, or you can call it this one. This is the principal plank. This is one is the minor plank. So plank is the surface below the adjacent of cutting edges. This is the major cutting edge. This one is the minor cutting edge, or principal cutting edge, or end cutting edge. So the surface below the major cutting edge and adjoint to cutting edges, that is nothing but a plank. So here two types of planks. One is the major plank. Second one is the minor plank, or principal plank, or minor plank. Okay. So these are the two planks are there. So we'll say what is principal plank or major plank. So major plank or principal plank lies between below the major cutting edge and adjacent to the side cutting edge. So this one is the major cutting edge adjacent to the side cutting edge. Okay. So similarly, minor plank or edge plank. So this is nothing but edge plank. So this is the surface below the edge cutting edge and adjacent to major cutting edge. Okay. So this surface nothing but planks. So planks are two types. One is the major plank or minor plank. Now we'll see. Uh, so this one is the that cutting edge, major cutting edge or the principal cutting edge. So next one. So this is the junction of face and the plank. So this is the face. This one rack face. This one is the major plank. The junction of these two faces nothing but major cutting edge. Okay. So this one is the minor cutting edge. So this one is the junction between the rake face and minor flank. So that is nothing but minor cutting edge or end cutting edge. You can call this end cutting edge. So now see, this one is the nose. This is very important. So the cutting point or nose, it is in curved surface like this one, just not in a exact rectangular point. So this curved surface gives the smooth surfacing, and the light level of tool will be increased. So that is the importance of the cutting point or nose. So it is very important. Okay. So this one is the junction of side and end cutting edges. This is the major cutting edge. This is the minor cutting edge. The junction of this one is the nose. No, we'll see. This is the nomenclature of single point cutting tool. Single point cutting tool mainly used in lathe machines and boring machine. So not boring machine. Okay. In shaping machine also, planing machine also, we'll use this type of single point cutting tools. Okay, here we'll see these are the parts. The first one is the shank. So to hold the uh, single point cutting tool in tool post. Okay. So next one is this is the rack face. This one. So on this face, the chips will slide on this face in upward direction. So this is the major plank. This one is the minor plank. This one. This is the major cutting edge. This one is the minor cutting edge. Okay. So this is nothing but nose. Nose, very important. So these are the different parts of cutting tool. Now we'll see what are the different angles in this cutting tool. So if you observe from the top view, two types of angles can be observed. The first one is the end cutting edge angle. So this one is end cutting edge angle. Next to side cutting edge angle. So this is the side cutting edge angle. Okay. So if you observe from the top view, okay, so end cutting edge angle we can see, and side cutting edge angle also we can see. Okay. So here we'll see the end cutting edge angle is nothing but the line which is perpendicular to the length of the tool bit, and the angle between the line which is perpendicular to the length of the tool and the cutting edge. So this angle is nothing but end cutting edge angle. So similarly, so side cutting edge angle is nothing but the angle between the uh, cutting edge, major cutting edge, and the major cutting edge, and the line which is parallel to the length of the cutting angle, cutting tool. Okay. So this is the line which is parallel to. So this is the line which is parallel to uh, length of the tool. So this is the cutting edge. The angle between these two is nothing but side cutting edge angle. So if you observe this one in from front view, so this is the top view. So if you have, so from side view otherwise, if you observe like this one, two types of angles you can see. The first one is the side rake angle, you can see. Next one is the side relief angle also. This one, and this one. Okay, so this type of angles we can see. The angle between this one, the angle between this one. Okay. So this is nothing but a side rake angle. This is the nothing but a side relief angle. Okay. So these two angles you can see if you observe from the side view, end view, end side view. Okay. So side rake angle is nothing but the angle which is the angle which is formed between the rake face and the line perpendicular to the line perpendicular to the length of the tool, or parallel to width or perpendicular to length of the tool. So this is nothing but a side rake angle. So this one is the just like uh, side relief angle. Side relief angle is nothing but the angle between the uh, flank surface. Okay. So flank surface and the line which is um, perpendicular to the tool bit. So this is the line. Okay. So this angle is nothing but a side relief angle. So from top view, you can see two types of angles. One is the uh, end cutting edge angle and side cutting edge angles. So from end view, from side view, you can see the two types of angles. One is the rake angle, side rake angle, and side relief angle also. These two types of angles you can see. So if you observe from this front view, so otherwise from this view, you can see two more angles. That is nothing but this angle. Okay. So this angle is nothing but back rake angle. Back rake angle. So it means the angle between the cutting edge, major cutting edge, and the line parallel to the cutting tool. Okay. So this is the that is nothing but a back rake angle. But if you see from this side, just front side, so we will see one more angle, that is this one. So this is the surface, like the angle between this one. Okay. This is angle, that this is nothing but a clearance angle. So end relief angle or clearance angle. So this one is very important. The line which is perpendicular to the base of tool, and this surface or flank surface, vertical flank surface. So the angle between these two, that is nothing but clearance angle. So finally, six types of angles are there. If you so first two is the end cutting edge angle and the side cutting edge angle. If you see from the top view, if you see from the side view, side rake angle you can see, and the side clearance angle you can see. If you see from the front view, so back rake angle you can see, clearance angle you can see. So these are the six angles are included in this single point cutting tool. So nomenclature of the cutting tool means the what are the parts which are included in this cutting tool, and the different angles in the cutting tool. So that is called the nomenclature of the cutting tool, single point cutting tool. We'll see what is the importance of different cutting angles. So nose radius, we already discussed this one. The importance of nose radius of nose. The nose radius increases the life of the tool, okay, and provides the better surface finishing also, because it has some curved surface. Because the life of tool will be increased, and we will get the better surface finish. So next angles, you see different angles already discussed that one. The various angles of the single point cutting tool have great importance in the machining by using the single point cutting tool. Each angle has its own function and speciality. So we'll see the first one is the, if you observe from the top view, two types of angles we can see. That one is the end cutting edge angle, next to side cutting edge angle, this one. The end cutting edge angle is nothing but the ends, it means end cutting edge, the angle between the end cutting edge and the line perpendicular to the cutting tool. So the angle formed between the end cutting edge and the line perpendicular to the shank, the line perpendicular to the shank. So that is nothing but a cutting edge angle, end cutting edge angle. So side cutting edge angle is nothing but the angle formed between the side cutting edge, so major cutting edge, and the line parallel to the shank, parallel to the shank. Okay, so these two angles are very important. Okay, next we'll see the back rake angle. If you observe from the front view, like if you see this one, mm, two types of angles you can see. So if you, okay, so if you observe from the front view like this one, here, two type of angles. One is the back rake angle, another one is the clearance angle. So we'll see that one. So back rake angle and clearance angle. So back rake angle is the angle formed between the tool face, the rack face, and the line parallel to the base of the tool bit. So that is nothing but back rake angle. So clearance angle, the angle formed between the minor flank and the line normal to the or perpendicular to the base of the tool, base of the tool. So that is nothing but a clearance angle or end relief angle. So it avoids the rubbing of workpiece against the tool. Okay. So there is a very important functioning of this angle. We'll see the importance of different angles in the machining also. Next, lip angle and wedge angle, it is defined as the angle between the face and the minor flank of the single point cutting. Okay, so these are the back rake angle. If you see from front view, this is the back rake angle. This one is the clearance angle. You can see. Okay, next to side rake angle. Side rake angle. If you see from the side view, just like a side rake angle, the angle formed between the tool face, it means rack face, and the line perpendicular to the shank. Okay, so perpendicular to the shank. So this is nothing but a side rake angle. Rake angle is very important for mainly formation of the chips or movement of the chips also. So next one is the side relief angle also. Okay, the angle formed between the major flank surface and the plane normal to the base of the tool. So that is called side relief angle. The angle, this angle avoids the rubbing between the workpiece and the flank surface. Okay. So this one also very important. This is nothing but side rake angle and side relief angle. Okay. If you see from front view like this one. So next, so these are the different angles from top view. So this one is the end cutting edge angle and end relief angle. You can see from the front view or side view, back rake angle and the lip angle also you can see, and the just clearance angle you can see. Okay. If you see from the front view or the side, just front of the tool bit, that one is the side rake angle or the side relief angle. So these are the 6 angles in single point cutting tools. Okay. So now we'll see the mechanics of the machining. Okay. So we'll see for the machining processes we require the tool geometry. We should know. For the machining, we have to identify which type of tool should be used for the machining. So that is very important. Next to mechanism of the chip formation. What type of chips are formed for the ductile materials and the brittle materials. Okay. So we'll see for the ductile materials, continuous chip formation. We'll see for the brittle materials, the segments of chips are formed. We'll see what are the importance of those things also. Next to chip thickness ratio also, you can see. what is the chip thickness ratio, what is the value of chip thickness ratio also. Next, build up edges also see. So because of overheating formed in machining, so some type of just weldings formed between the workpiece chip and tool bit. So we'll see what is the build up edges formation, what are the causes and characteristics and effects of build up edges we'll see. Next, classifications of machining chips also we'll see. Next, tool material, what are the different tools and different materials for the tool making we'll see. So all these things we will cover in this chapter. First of all, we'll see the importance of the rake angle. So because we already discussed the different angles which are incorporated in the single point cutting tool, in which rake angle is very important. We'll see what is the importance of this one. So just if you consider this is the tool like chiseling point. So here two types of angles we can see. This is the just like general machining process diagram. Okay. So here, so this is the cutting tool. We can assume this one. This is the workpiece. So okay, the chips will be formed like this one. The so this moves on the rake face. This is called rake face. So the angle between the vertical line, this is the reference line, and the rake face. So that is called rake angle. So that is the very important angle. Okay. Based upon the rake angle, so we can see the formation of chips also. So one more angle you can see here, that is the clearance angle. So clearance angle is the this is the end cutting edge angle and the line which is perpendicular to the shank. So you know this one. This is the clearance angle. So this clearance angle is must be needed to reduce the roughness rubbing between the tool and workpiece. Okay. So this is the cutting point nose of this one. So by using this point, you can perform the machining operation. Okay. So this is the flank surface. So minor flank surface as you can see. Okay. So this is the general diagram for the machining. So here just like tool movement, this is the tool bit. So this one is the reference line, the angle between the reference line to uh, this to this is the rack face. So that is the angle, rack face angle, rack angle. So next, so this one is the clearance angle. So it means the flank surface and the line which is perpendicular to the or which is so perpendicular to the shank. So this is not a clearance angle alpha. These two angles are very important. So you can see represent this one. Rake angle is the gamma and the clearance angle is called alpha. So this controls the flow of this sliding of the chips. Okay. So different types of relief angles also you can see, and uh, clearance angles also very important. This reduces the rubbing between the cutting tool and the workpiece also. Okay. So the movement of workpiece, rotating of the workpiece here you can see. So definition of the rake angle. So what is the definition of rake angle? So rake angle, the angle of inclination of a rack surface, the face, top face of the tool bit from the reference plane. Okay. So rake angle is provided for easy of chip flow. So easy slip chip movement, chip sliding on the face, okay, while machining is performed. Okay. So rake angle may be positive or a negative, even zero also. You can consider this one. Okay. So we'll see what is positive rake angle, what is the negative rake angle, and what is zero rake angle. So what is the importance of this type of changing of rake angles? Also? So here we can see this is the just like positive rake angle. This one is the reference line. So the surface, it means the rake surface, the tool bit is below the reference line. So the angle between the reference line to the reference plane to and the rake surface, that is called rake angle, the positive rake angle. So the positive rake angles helps to reduce the cutting force mainly, and the cutting power also will be uh, so cutting force will be reduces, and thus cutting power requirements also will be reduced. Next to negative rake angle. So because of positive rake angle, uh, just to can reduce the mm, cutting force. Okay, so we'll get these smooth surfaces also here. uh, so next one is the negative rake angle. Negative rake angle means uh, when the tool bit, so here uh, the flat surface of the tool is uh, above the reference plane. So above the reference plane, just like this one, this is the angle between the plane and the reference plane. So this is the negative rake angle. So negative rake angle is to increase the edge strength. Edge strength means here less cutting force required in positive rake angle. In negative rake angle, require the high strength. Edge strength should be uh, increased. So required means it increases the edge strength. So for ferrous, non-ferrous materials, we can use the positive rake angle. For the hard material, we have to use the negative rake angle also. Zero rake angle is simply simplified design and manufacturing of the farm tools. Okay, you can see. So we'll see what are the importance of rake angle also. Rake angle just to it increases the tool life. So based upon the rake angle, you can increase the life of the tool. It reduces the cutting forces as well as the power required. Okay. So if it is positive rake angle. Okay. So next, it allows the chips flow a convenient direction. That is the importance for the rake angle also. It gives the sharpness to the cutting edges. It increases the surface finishing also. Okay. So mainly this one, the positive rake angle. Positive rake angles are used to measure low strength materials because the positive rake angle takes the less cutting forces. So by using the positive rake angle, you can perform the machining operation on low strength materials and the non-ferrous material, just like aluminum, magnesium, silicon. So performing of machining on non-ferrous materials, you can choose the uh, positive rake angle. Okay. So next, to cutting tools with the negative rake angles, so are stronger and are used to cut high strength alloys, just like all ferrous materials. For this one, you use the uh, negative rake angles. See? So this is the basic feature of single point cutting tool. So the workpiece will rotate like this one. You can calculate the RPM of this workpiece pi d n by 60, like this one. D is the diameter, N is the speed. You can, by using this one, we can calculate the velocity of this one. Okay. Okay. So cutting velocity, you can find out this one. So next, this is the side cutting edge angle. You know this one. This one is the main cutting edge angle. Uh, the cutting edge angle, the angle which is parallel to the workpiece, and the cutting edge angle. So that shows the clearance angle. So clearance angle reduces the rubbing between the workpiece and the cutting tool. This is the cutting axis. You can see this is the cutting axis. So this one also, this is the nothing but a side cutting edge angle. Okay. So you can see this is the all the different types of cutting angles and the nomenclature of the cutting single point cutting tool. You know this is the shank, this is the rake face, and uh, this one is the flank face, minor flank, major cutting edge, minor cutting edge, and different types of the angles, back rake angle, side relief angle, just one end cutting edge angle, this one side cutting edge angle. So all this nomenclature here, which are already discussed in previous slides. So now see what are the factors affecting the rake angle. Because of the rake angle, so okay, based upon the material strength. So for performing the machining on high strength material, just you have to take the negative rake angle. For the performing the machining on low strength or ferrous materials, you can take the positive rake angle. For the general purpose for farming, you can take the zero rake angle. Okay. So type of material being cut, so it influences the rake angle, and type of tool material also it influences the affecting the rake angle. Next, the depth of cut also very important. Okay. So here you can see rake angle values for aluminum. That is the just like positive rake angle 12 to 25 you can take. For the brass 3 to 14, bronze just like 5 to 14, cast iron, gray iron, that is the 0 to 6. You can see this is the negative rate angle also. Copper is the positive. So PVC is the positive. Stainless steel, this one. So these are the different rake angle, optimized rake angles for the performing of the machining on different materials. This type of materials. Okay. We'll see what is the how chips are formed. Uh, Otherwise, you can see the machining how the chips are removed from the workpiece. So during continuous machining, so during continuous machining, the uncut layer of the work material, just the head of tool bit. So this portion is subjected to almost all. Okay, so here we can see the chip formation when the tool bit is moving forward direction. The portion which is in front of the tool bit, so this portion is subjected to different types of so stresses. So we'll see the compression stress. So automatically, due to this compression stress, the material will be sharpened. So and some deformation takes place when the this compression force is in, this increased the yield strength of this material. The material will be teared and forms in the just removed in the form of the chips like this one. Okay, the force exerted by the tool on the chip arises out of the normal forces. So three types of forces you will see. That is the force, cutting force, the thrust force, or normal force. This one is the resultant. Okay, so you can see radial forces also. One more force. You can see three types of forces you can take. So we'll see what is going on this one due to such compression when the tool bit is moving in front of just against the workpiece. The shear stress will develop within the compression compressed region. So in this region, shear stress will be improved. Okay, so in different magnitude, so in different directions also rapidly increases in magnitude. So whenever and wherever the value of the shear stress reaches to shear strength of that working material or workpiece material, so in the deformation region, so or yielding us chips, chip takes place, resulting automatically shear deformation in that region. Okay, along the plane of the maximum shear stress. Okay. Here, this one. So when that so the shear strength of that work material, so in the deformation region, okay, so it exceeds the yield strength of that particular material. Automatically, shear deformation takes place. Okay. So, but the forces causing the shear stresses in that region of chip clip that quickly diminishes and finally disappears when that region moves along the tool rake surfaces. Okay, so due to that one, the material will be removed in the form of chip that slides on the rake face. Okay, so as the result of slipping or shear stops the propagation long before the total separation takes place in in the meantime. Okay. The succeeding portion of chip starts undergoing the compression yielded by yield strength and the shear. So this phenomenon is repeats rapidly, resulting in the formation and removal of chip formation. So in this way, the chip will be formed in the machining, the layer by layer. We will see this one is the chip thickness ratio. So R is equal to uncut chip thickness by chip thickness. Okay. So T naught is the uncut chip thickness. So R, so the chip thickness ratio T naught. So this one is the thickness of the chip. You know that T naught is uncut chip thickness means so thickness of the chip to form the chip. Okay. So it is represented by T naught. That is the uncut chip thickness. Next, TC is the cutting chip thickness. Okay. So this cutting chip thickness, due to the shearing, the value, the size of the chip thickness will be increased. So automatically the TC is always greater than the T naught. So the value of ratio of the chip thickness always less than the 1, because TC is always greater than the T naught. So chip thickness after cut is always greater than the before. It means TC is greater than the T naught. The chip ratio always 1.0, you can say. So here just like the formation of chips by the just phenomena of Fishman, just like arrangement of some play cards. So in this way, just chips are removed from the shearing area. You can see this one. So this is the just like mechanism of chip formation. So when chip is forming, so the heat will be developed in this due to this friction. This is the major heating area. So this one is the minor heating area. So this is the another heating. So 3 regions we can see. In next class we'll see the what are the different types of region. What are the different phases of temperatures will be developed in the machining. We'll see. Okay. Thank you for the listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.